Hello, everybody. My name is Nicolas Gastelum, and we are going to be covering Chapter 6.1, the area between curves today. So the area of a region between two curves is going to be shown here. We have f of x and g of x, and we are trying to find the shaded area in the middle here within the interval of a and b. So essentially what we are doing is making a bunch of tiny little triangles in between each of the lines right here, and that's given by the equation here and simplified by the one right here that we're mainly going to be using in order to find that area in between the two graphs. So conceptually, essentially what this is it is f of x minus g of x. So the graph of f of x is going to be everything below f of x that we're finding, but we don't want everything below it. We want things that are above g of x. So to do that, we subtract f of x is subtracting g of x, which is going to be everything below g of x. And that right there will then help us find the values right in between. So in short, that is essentially what we're doing with this entire lesson, kind of more explained conceptually. And of course, that is using the main equation right here. So let's go ahead and move on to example number 1. So right here we are bound, there's a graph. We have f of x, and then is x plus 4 below by the graph of g of x, which is 3 minus x over 2 in the interval 1 to 4. So the best thing to do first is to just go ahead and graph those right there. So x plus 4 is just going to be a nice straight line, plus 4, kind of going up like that. And then 3 minus x over 2, same thing. Kind of put it at 3, make it a little bit higher right there. And then, of course, it's also going to be 3 minus just 1/2 of x, which will be, oh, don't want to do that, just kind of a line like that. And then it is also to just the interval of 1 to 4, which is going to be from here to here, and we are just finding, whatever is right there in the middle. So as we saw before, this essentially is going to be f of x minus g of x 1 to 4. It is also can be known as top minus the bottom, which is crucial for some of the later problems that we're going to be doing. So let's go ahead and set that up. Is going to be integral 1 to 4. Of course, also can't forget the dx. X plus 4 minus, put in parentheses, the g of x, so you don't forget about distributing the negative. 3 minus x over 2 dx. Just simplify to x plus 4 minus 3 plus, you can just go ahead and change that to 1/2 x dx. We'll go ahead and combine like terms, which is then just going to be 1 to 4, and then we'll combine these two, 1, 2 plus 1, get us to that 3 over 2. 3 over 2x plus 1 dx. Go ahead and find the antiderivative of that. What I like to do is kind of visualize it, cancel it by 1. So we're adding by 1, which will make this square divided by 2. So then we are going to get it being multiplied 3 over 2 times 1/2 x squared plus x is that 1 turns into, which will then just be 3 over 4. Let's see here. X squared plus x from 1 to 4. And then it's as simple as just doing 3 over 4, 4 squared plus 4 minus, and since it's only 1, it's just 3 over 4 plus 1. Alrighty, so go ahead and plug these values into a calculator, see what we will get. So essentially is going to be 16 minus 1 minus 3 over 4, which is going to get us 14, 1 over 4, which is then just going to equal 57 over 4. It's going to be your answer right there. So now to level it up a little bit, this is going to be the area of compounds regions, which is essentially the area, it's still kind of the same, but it's going to be where the curves cross. Like we see down here in checkpoint 3, the curves are going to cross right at that point there. Right here at x is 1. So because of that, essentially what we are going to have to do is split up the integral. So it's going to have to be 0 to 1 for f of x, and then 1 to 3 for g of x. So that's going to look like, just write it down here, 0 to 1, root x dx. And kind of to write it in the terms that we had before, showing the f of x minus g of x, would essentially just be root x minus 0, since it is the x-axis is at the bottom, and it's going to be that. And in order to get the entirety of the area, we're just going to be adding both of them. So then now for g of x is going to be 1 to 3, 3 over 2 minus x over 2, and then just that 0 in there to visualize it a little better. So essentially what that becomes, if we kind of do a little bit of fast forwarding, this is going to be x to the 1/2. So x to the 1/2 plus 2 over 2 gives x to the 3 over 2. And then since we're dividing by the fraction, we are essentially just flipping it. So it's 2 over 3 x, 3 over 2, 0 to 1, plus 3 over 2 x minus, and this is going to be a lot like the last problem that we have, where essentially this is 1/2 x. So then got to add the 1. We'll make it 1/2 times 1/2 x squared, which will then just go to 3 over 2 x minus 1 over 4 x squared, and then that'll be from 1 to 3. So then the two values right have here, go ahead and plug them into a calculator. I think the better way of doing it as well is to go ahead and just do it here. Let's see. 1 to the 3 over 2. Just yeah. So then it's just going to be 2 over 3 minus 0 plus second derivative over here. It's going to be 9 over 2 minus 9 over 4 minus 3 over 2 minus 1 over 4. And that is all going to equal 5 over 3. Right there for the next answer. Alrighty, and then on to the next part of the lesson, which will make some other graphs later on a lot easier than what we've been doing, where we had to, in this previous example, had to split them both. Now we're learning that about regions defined with respect to y, using the y-axis. So we have D and C. It is essentially the same as before, except it's going to be using y's. U of y minus v of y d to dy, and D and C, since it'll be y values. And now instead of top minus bottom, it's just going to be the right minus the left, which, as you can see up here, is u to the y minus v y. Since within the shaded region, it's the orange minus the blue. And now we're doing, instead of vertical rectangles, we're doing horizontal ones now. So cutting back to the original, the problem we actually just did, we can go ahead and see that it makes it quite a lot easier when we do it. Since now, instead of having to split the the area and having to do the different integrals, we just do what's on the right minus what's on the left. So this time it's just going to be 1 to 0 as well is going to be the values for the integral, our interval, since it's going to be y values instead of x's. So 0 to 1, and it'll be right minus left dy. As well, it is in dy, so that means we are going to have to change around the values from being y equals x. It's going to have to be x equals y, since we're doing it with respect to y. All right, so then essentially what that comes down to is, so the y equals 3 over 2 minus x over 2. Go ahead, multiply the 2 out. So then it'll be 2y equals 3 minus x. Add the x and subtract the y. 2y. X equals 3 minus 2y. That's one of the most important things, is you have to make sure that is going to be x equals the function in y's. That's the most important thing with switching these problems over. So now for the other one, it's going to be y equals square root of x, is essentially just square both sides, x equals y squared. So doing it right to left, 0 to 1. On the right is the g of x. So we're going to have our 3 minus 2y minus y squared. is then, and dy is then just going to be, without the parentheses, go ahead and take the antiderivative, 3y minus y squared minus 1/3 y to the third, 0 to 1. It's going to be, we like these numbers right here. 0 and 1 make it a lot easier. So it would just be 3 minus 1 minus 1/3, which, as you can tell, is then just going to equal, from the calculator, make it a lot easier. 3 minus 1 minus 1/3 is going to give us 5/3. It's the same answer as before, just a much easier, quicker, and simpler way to get there. And then here we go on to our last example here, where we don't have a drawn graph. We're going to have to draw it ourselves. So as well, with respect to y, which is nice, it is already in x equals, so that makes our job a lot easier. So from here, it'll just be x equals negative y squared, and that one's already done. So we'll go ahead and just draw this first so we can kind of get an idea of what this looks like. X equals y squared is, let's draw a better graph here. So that's just going to be a leftward facing parabola, and then this one here is going to be in green, y squared plus 1, rightward facing to the right 1, here and here, and then y0. So that's just going to be at the bottom, which will be a horizontal line at the x-axis, and y equals 3. Put that up here, and that's going to be our top interval. So what this is doing is giving us, we're trying to find the area right in here between all of those lines. Same thing, it's going to be 0 to 3, right minus left, dy, 0 to 3 is going to be, of course, the g of, or we'll just call this g of x, it doesn't really matter, but it's the one on the right. It's going to be y squared plus 1, and then on the left is negative y squared. Since we're subtracting, we'll go ahead and add the y squared dy. So combine all of the terms, 2y squared plus 1 dy, and that's just going to be, let's see, 2/3 y cubed plus y, and going to do that on the calculator right now. 0 to 3 is perfect. It's quite simple. Actually, you don't even need the calculator. So 2 to 3, 3 cubed plus 3. Let's go ahead and actually just double check. 3 cubed plus 3. It's going to be a nice number of 21. So that right there is going to be the lesson today. Thank you very much, everybody, for watching. Got to remember, once you're done learning it, it all just becomes simple math. Thanks so much.